So where I go. Thank you, everyone. Hopefully you can hear us loud and clear. Thank you so much for making the time for joining this session. We're really looking forward to sharing some insights and, of course, gaining some insights for all the participants as well. I want to kind of raise a quick point here. I think we all see these breaches in the news every single day. Caitlin just touched on, one thing she does very well is helping to spread the news about how to implement best practices. Um, Breaches across financial services and other sectors involving static encryption, key vulnerabilities, they've led to significant extortion demands. We see it in the news every day, ransomware, malware, and so on and so forth. And this highlights the urgent need for advanced security solutions. Today's webinar is going to be an opportunity to feature some leading experts discussing both the immediate cybersecurity challenges as well as some of the post-quantum cryptography readiness solutions that we need to be thinking about now, not yesterday, but now. And importantly, how SQE's keyless entanglement technology effectively addresses these evolving risks. And so it's going to be very much an information sharing sessions. And with that said, I'm going to hand over to Caitlin to kick off the interview with our boss, Hamid.
Yeah, thank you so much, Dennis. I appreciate it. And I'm honestly so excited to be on this call. When the SQE team reached out to me, I don't even know, like a few months, no, probably like 5 months ago at this point, and they kind of showed me everything that was going on and what they were doing and all their patents. I was floored because quantum computing is getting so much closer. It's already pretty much here. And like, how are we going to tackle that as a cybersecurity team? I feel like as people in cybersecurity, we have to work together. So I like to say cybersecurity team, but most of the stuff that we currently do for cybersecurity hygiene, cybersecurity awareness is going to be completely outdated once quantum computing hits. And a lot of the tips that I give my followers, which is, passwords, multi-factor authentication, like a lot of that just going to like disappear because that is not going to be a risk anymore because quantum computing can kind of completely crack the current encryption codes. And there's a lot of stuff going on. So when I heard about this, I was really excited, but I was also very sad that I couldn't talk to anyone else about it. So I'm very happy that it's now coming out of stealth mode. And I'm really excited to really introduce you to Hamid, and we can kind of walk you through the kind of landscape of cybersecurity, where it's going, what quantum computing really is, because I love kind of breaking it down into simple terms, and really how SQE is leading the pack and all the patents that they're working on and or that they already have. And so just a quick intro about me. I'm Caitlin Sarian. I've been in cyber for now 13, 14 years. I really specialize in breaking down complex cybersecurity tips to the general public. And I'm now the largest cybersecurity educator in the world, which I'm so honored to be. But I feel like it's always my duty to kind of lead the next generation into the new, not trends, but the new way of living. And that's why I was so excited about SQE reaching out and like really seeing everything that they have. So on that note, I really wanted to introduce Hamid and have Hamid kind of introduce himself and also kind of introduce what quantum computing is for our audience and like how it's different than our traditional computing. So Hamid, if you want to take the reins.
Yes, thank you, Caitlin. It's really an honor to meet you, and I'm so glad that you decided to join our group. We have an unbelievable set of people who have been helping us to make this a possibility, and thank you. My name is Hamid Pishtarian. I am the CEO and founder of SQE. I have always been an engineer. I think I remember the first time I invented something, I was under the age of 10 years old. And I've just loved engineering, every field of engineering, not just computer science, but by schooling, I'm a mechanical engineer. And as well as I've developed probably a couple of million lines of code over the years. And I think last time I counted, I've used like 40 different computer languages. But my passion has always been artificial intelligence. I think the first time I developed a really intelligent system was to actually track satellites when I worked for the company TCOM Electronics back in Toronto. I think it was 1992. And so ever since then, I've been just developing products for different fields. But my passion has really been just development, consumer product development. And so when I was faced with a serious problem that I had while I was working on a project in sensing and for agriculture, I realized that I needed to add security because this is in open field. And that's when I was a bit shocked when I saw that the cost of security is actually higher than the cost of the sensor that I had designed. It was kind of like a shocker. Well, I'm trying to create a low-cost product for farmers, and then the cost of security is just making it so it just is not feasible. At that point, I always been a mathematician ever since I was, I think, 5 years old, and I love quantum physics. So when I learned about quantum entanglement was probably back in the 90s, and I was absolutely amazed what are the amazing things that it does. And so even though I'm not a physics major, I'm not a physicist, but I love science. So when I realized what quantum computers can do, I was really shocked that they can pretty much hack anything. In fact, we have no idea what is the power of a quantum computer. We have no idea. We think we do. Every time I look at it, it does something but more amazing. Imagine if you had a system where it could pretty much solve any problem, given some of the limitations. But once those limitations go away, essentially there are no problems that it cannot solve. So the question is, can it solve massive number of massive problems, like problems that are just so large that are just unimaginable? And so that's basically about me. I'm an engineer by nature.
Yeah, I love that because we're both engineers. We both did mechanical. So it's so interesting. And I love how you explain quantum computing. It's basically like a problem, no problem can be like unsolved with it. And the way I kind of try to describe quantum computing to like the general public, right, is like normally our normal computing is like a really, great librarian, right? You need a book. The librarian knows exactly where to go. They go get the book and they give it to you. Quantum computing is kind of like a magical librarian. Like they can just kind of conjure it up out of nowhere and then it just like goes directly to you. You don't even need like a person in the middle. But I know with the rise of quantum computing, it kind of makes traditional cybersecurity methods more vulnerable or kind of non-existent. So can you kind of describe like how quantum computing and the work that you're doing at SQE, like how it's going to tackle kind of the cybersecurity aspect of protecting ourselves when it comes to quantum?
Yes. So when I was looking at this problem with the sensor security, one of my hobbies is quantum computing, and another hobby is following Stephen Wolfram's model of physics. One day I was just thinking about this problem and it just hit me that I can actually simulate quantum processes. For example, quantum superposition, which is everybody's doing that, by the way, now. But it's more important the quantum entanglement itself can actually be done using classical computers. That seems a bit like impossible. And that has been one of our issues. But believe it or not, it is not impossible. If you take a look at what is the definition of entanglement. Entanglement means that essentially a particle or a set of particles are created at the same time at the same location. It's just a matter of space and time. If you have two particles created, so when I added that to Wolfram's model of physics, I said, well, why can't I create my own virtual universe? I can basically create a virtual universe out of nothingness and essentially create them and put them in a small microcontroller and essentially basically make two particles, not exactly the same, but somewhat the same, using a quantum processes, which, by the way, everything around us is in the state of quantum, whether you like it or not, right? I mean, that's how the whole universe is made. So I just took some of the particles that is received by an antenna, which basically creates a random processes, and I record the processes that as a whole create a quantum particle. For example, spin or polarity, and I just digitize them, and I put them in two different pieces of hardware. And essentially, once you convert it from an analog system to a digital, all you have to do is essentially follow a method of simulation. And now you have two different devices which you can just put on a truck and ship it somewhere. And now you have entanglement at two different locations, which is exactly what a quantum entanglement is. But you need more than just quantum entanglement. You need the superposition, but most importantly, you need observation. Observation is one of the properties of quantum physics, where without it, really nothing exists. So I created an observation process, which, by the way, I didn't. I created a system where the particles, what I call time particle, observed itself. So by combining everything, we are able to create this system where essentially you no longer need private public key exchange. And that is really what is SQ all about. If you don't have a key, you can't hack it.
Yeah.
So the idea is to remove the attack surface. And it turns out that it actually works.
Yeah. So can you kind of explain a little bit? So right now we have our standard encryption, right? How is that like not relevant anymore with quantum? And then how is SQE kind of fixing that?
Well, back in the 90s, I believe, Peter Shor discovered how to use quantum processes to essentially make RSA algorithm kind of like obsolete. So you can always make the RSA algorithm, which creates the private public key exchange possible. Well, because of the power of quantum computers, meaning that they have infinite power, right? In other words, every possible solution is already there. You just have to find the right solution. What it means is that it doesn't really matter how complex the problem is, which is exactly what prime numbers do for the private public key exchange. Well, essentially, it gives you the entire solution. So what you have to do is you have to go find the right one. And Peter Shor had one methodology to do it. There are other processes as well. So it doesn't really matter how complex you make your encryption system. As long as you have an encryption key, the quantum computer has the possibility of decrypting it. So I could not find any solution around it. I think the solution was just to get rid of the key. Okay, it's like we don't really know how powerful quantum computers are, and because we don't know how powerful they are, therefore we really don't know what protection we can have against it. So, but by removing the need for the key, that pretty much, that I believe, in my opinion, solved the problem. So we created a system where essentially people and the people, things, they all become entangled through a process that we call proof of entanglement. Two things are connected to each other because of the ID system that we created. And this ID system is called SQID. Anyone who registered with SQE platform essentially gets an ID. And through this ID system, we create these extremely large numbers that are 1,000 digits, that are, even for a quantum computer, it would take a long time. But more importantly, it would take infinite amount of energy to identify them. But another function that we had to add in order to make sure that quantum computers even cannot attack us was literally the fact that we never retransmit the same code. So every single communication, excuse me, every single communication has its own code. So by the time the quantum computer wants to attack it, it's already changed. So that is really how SQE is solving this issue, that kind of like getting away with impossible. Because if you have a different key every single time and the keys are 1,000 bits, then by the time any system wants to even define the problem, the question is changed. So you can't come up with a solution to a problem that you're not aware of. It doesn't matter how much power you have. That's the approach that we're taking. And I hope that answers your question.
No, it did. And I think that it brings up another interesting question is the way that you guys have patented and the way that you guys are solving the quantum computing problem. There's so many use cases to use it with, right? We have so many cybersecurity problems. We have deepfakes, we have cyber warfare. And I just see the reason why I got so excited about SQE is I really see it fitting into every single area of kind of I don't like to say digital landscape because it sounds very chat GPT, but it really does fit into every area of like the online landscape for everything that we use. And we're able to kind of, like you said, you have your unique SQE ID that really, and then also how it constantly changes. So they won't ever kind of trace back to you. But I would love to get your opinion on like what you're most excited about, like what problem that SQE solves that you're most excited about that it's kind of like solved in the quantum computing realm.
Well, I think one of the information about people is their private information. I think once you solve that problem, which really directly goes into a KYC problem, if you can secure my information so that only I have access to it, it doesn't matter where it is. It could be in a database, it could be on my laptop, wherever. If I can secure that information, then in my opinion, you've solved all the problems. Every problem that we have is really a KYC problem, in my opinion. The reason is because if somebody can pretend to be me, then it really doesn't matter what security you have, right? Well, I should be able to access, which means essentially if somebody pretends to be me, they have access to everything about me. So solving the problem with KYC, in my opinion, is the most important problem. But having said that, this notion of security, direct, as you said, applies to every field. So an SQE as a startup, it just doesn't have the power to go after even 1% of them. So we created a platform where people can come in and solve their own problem. So our goal is to create a set of tools that people can use for any field that they're interested in, and either partner with us, just use us as a tool, or as an individual, you could, for example, store your information in what we call Qverse, which is our database, a distributed database that we have created. And essentially, it's your data. For example, just to let you know, I do not have access to my own information. As the creator of SQE, I do not have access to my own information unless I follow the right procedure. So we had to create a set of tools to make this possible. It's not like one thing that I can point, okay, it's because of that or it's because of that. It's mainly because of SQE, simulated quantum entanglement. But it's really a host of technologies that we discovered over the last 2-3 years that we need to create these technologies in order to make it possible. So I'm just going to go through that list really fast. And over the course of next few months, Caitlin, as you know, we will be introducing all of these technologies. But just to name them, we had to create a brand new smart contract engine. We had to create Qverse, which is a NoSQL NoSQL database, is a vector engine, and which we use for user verification as well as other things. So no information on SQE is ever not encrypted. Everything is encrypted, 100%, from the moment the information is generated by the user until the information is stored in the backend somewhere, and that could be your laptop. It's a distributed engine. It's all encrypted, and it's only available on a need-to-know basis by the right people. For example, if you want to send a text message to someone, only the person who's the right person becomes entangled with you through our hardware entanglement, which obviously we need to spend a lot more time to describe. So through this process, only the two of you have access to it. And this could be an IoT system connected to another IoT device, or it could be an IoT system connected to someone's backend, or it could be a person himself is connected through his mobile phone or his laptop connected to another person. Essentially, only the endpoints have access to it. And which also brings us to, we need to make sure that even when the data is being generated, so we are introducing the notion of KYD, which is knowing your data as well, because if somebody can fake the data, then it really doesn't matter what level of security. So we went through every aspect of security one by one and found out what technology do we need to create in order to secure that aspect of it. So it's not one thing. It's data transmission, it's data generation, and data storage. Let me just tell you one thing about our storage. We do not use standard encryption methodologies. We have created our own methodologies. They're generally based on a version of cellular automata that we have invented. But these methodologies require no key, meaning that I can store my information, but I don't have to have a password for it. The information seems like appearing out of nowhere and being decrypted for the right person. It seems like impossible, and then frankly, that's one of our biggest problems. People don't believe us. So what we want to do today, show all of some of this technology, how it works, and hopefully we can attract people. But you know, just to give you an idea, if you had a 1 megabyte file, we will have 8 megabit of key. Since we don't have to transmit the key, well, why keep it at 256 bit? And why does it have to be fixed? The key changes with every single bit of information. And that is something we will showcase today.
Yeah, I love that. Again, there's literally so many uses, and I'm so excited to see what everyone uses SQE for. But I already have so many that I would like love to see people start using it for. I know we're over time, so thank you so much, Hamid. And I will hand it to Jake, who's the head of development here at SQE, or not here because I'm not with him, but head of development at SQE.
Thank you, Caitlin.
All right. Awesome. Oh, can you guys hear me okay? Awesome. Thank you. That was awesome and super informational and really kind of segues into what I'll be showing you guys today. So hello, everyone, and thank you for joining us today. My name is Jacob Rausch, Head of Development at SQE, and what you see on the screen here right now is the SQE Sandbox launch page. This is where every session begins by entering your unique session code. Today, I'll be walking you through the SQE Sandbox, a live demonstration of the quantum secure foundation we've built to protect data, identities, and communication, and a bunch of other features, as Hamid has just previously mentioned. You'll see how each user is assigned a 1024-bit decentralized identifier known as an SQID, created instantly upon registration. From there, we'll dive into a passwordless login process and witness browser to backend entanglement through the use of our zero-knowledge keypad. Our encryption framework eliminates the need for traditional public key cryptography, delivering the same trustless security, but without the exposure. Once inside the dashboard, I'll show you two of our core use cases, secure messaging and simulated secure payments. Though we believe, as we've previously just talked about, this is just the beginning. This is the tip of the iceberg of what this technology really enables. So to learn more after today's demo, visit sqe.io or explore our YouTube channel, sqe_secure, for deeper dives into the SQE ecosystem. We have visuals, explainer videos that kind of go into each individual specific topic, like our SQIDs, our hardware devices, and whatnot. So let's get started by entering our session code. In this case, it's 1234. And once you type in your valid session code, you're going to be brought to the registration and login page. And so here you'll see a few different things. You're going to see information pop-ups on almost all of our pages that give kind of a summary of what I'm talking about today for future reference to go back to, as well as where you can learn more about specific topics. And so essentially, we have just a basic user form for registration. We have the username, we have your email, first and last name. That's all that's required for this sandbox. It's important to preface that this is just creating a temporary SQID, so it's not reliant on your real personal user data, but to create a level 2 registration, what we call that gives us enough information to be able to validate and verify you to create and receive secure payments. We show that the date of birth, social security number, other things that we can that are essentially permanent to you, that we can tie the SQID, the encrypted information based on your user profile, to identify you and uniquely tie it to your user profile. And so we also have a drop-down menu, as you'll see, with our banks, that you can choose any one of these 4 banks, and that essentially just simulates a bank account that you may have that allows you as a user to simulate bank transfers, sending and receiving payments. And so essentially, once you create that account, before the SQID is created, you're brought to our graphical keypad page. And this is really where the magic happens in allowing to secure your browser and initiate that entanglement that we just talked about between the browser and the SQE network. So right now, you're going to see a few different bitmaps emerge every 5 seconds. All you have to do is click 4 points at this time, and that would be enough to, using zero knowledge principles, to create that initial entanglement, create that quantum secure session for the browser and the SQE network to send encrypted and be able to decrypt those packets without having to send a key in the process. And so what we can also talk about here is how this keypad is essentially can scale in complexity, right? So not only can it be used for initiating that entanglement, but it's also will be a tool for human validation using behavioral biometrics, so that you can go through and register through your SQE account without a password. So it's a passwordless login, as well as previously talked about, AI resistance, making sure that you as the user are who you say you are when you log in. And so we'll do a deeper dive into the login process here in a couple minutes. But what you'll see is essentially that keypad. You can click any 4 digits. It's not a pin. You can select any 4 numbers every time that you want to entangle yourself with the network, and boom, that's it. That's now you're entangled. We just registered. We were given a 1024-bit SQID that was created through our network based on, again, that temporary user profile that we're creating in this Sandbox environment. And what you're going to see is a few different things on this dashboard page. It's important to also understand that everything, now that we are entangled, now the browser and the backend are now in sync with each other. The keys are evolving fast as time goes on. And so every packet that is sent on and received between the front end and the back end are now going to be wrapped in our SQE quantum secure bit level encryption. And so to kind of describe a few things on this dashboard, you're going to see the SQID right next to the username at the top. We have our informational button here that kind of gives a rundown and a summary of kind of, again, what I'm talking about today in the different tabs that we have on our page. You can view the full SQID by hovering or clicking and being able to take a closer look at that. We're going to be having a lot of new releases and features to be able to get users to, test our ecosystem and the different features. So we have that report issue button as well to continue to improve this Sandbox page. And so now here, what you see is our payment field. And this is to demonstrate to you one of our core use cases, secure payments. And so we really want to preface that this is just one of the many use cases that can be available. Right now, our secure payment is wrapped in ISO 222 compliance, but this encryption wrapper, the idea of this using the SQE encryption as a wrapper, can go around any existing architecture. It's not a rip and replace. It's a cohesive tool that can be added as a secondary layer to whatever encryption is already in your tech stack, as well as be also, because it doesn't rely or eliminates the need for public key cryptography, it can be a very strong secure primary control as well. And so as you just saw, we just sent a payment to virtual Alice. If there's no other users that are active, we always have 3 virtual users to be able to demonstrate these core use cases that I'm talking about today. You can see that it's in progress. Each milestone is happening live, and that we are tracking each milestone to, again, simulate the different points that are happening for a safe and secure delivery. We have our information button as well that goes over each of the different tabs and what's going on behind the scenes. We have our audit report here that shows the payload of every single milestone being hit, again, through the use of the ISO 222 compliance. We map each milestone to the controls based on that compliance. And again, this is a wrapper, so we can wrap this with any compliance, which we'll show later on with our compliance mapper. Here we have what really the thick of it here is, this is the encryption, right? So we want to be able to display that encryption for everyone and be able to see that bit level encryption that Hamid was just talking about. You can see that there's no correspondence, there's no patterns, it's fully random. And again, time is evolving. So the back end and the front end are perfectly in sync with each other to be able to encrypt and decrypt these packets. Right now, what you're seeing here is the initial payload. So the moment you send that payment, the initial payload, which you'll see here in a second, the decrypted version is being encrypted. That's what you see here. And then the backend receives that encrypted version. Because it's in sync, it's got that entanglement initiated by our zero knowledge keypad. We can then decrypt it on the other side, and it will receive a response that you saw. And so here, what I'm going to do now is log out. Where we see that the account balance updated, and we're going to describe a little bit about our login process now. So we retype our session code, And then in the login, you can see, as previously mentioned, this is a passwordless login. All you need to log in right now is the username, and then we get brought back right to our zero knowledge keypad. Again, we have a login specific informational pop-up for anybody, any users to always reference to get the behind the scenes. And so what I'm going to do here is type Jake123, and we're brought back to our zero knowledge keypad. And as previously mentioned, this is going to update every 5 seconds until 4 points, random points are clicked on the same image. And then that's going to, using zero knowledge principles, create and re-entangle ourselves with the SQE network to continue sending that encrypted SQE encryption. And so we have re-entangled ourselves. We're now logged in. And again, that zero knowledge keypad is just kind of the foundation for initiating that entanglement. You know, we have further features that are going to be able to perform that user verification and AI resistance, you know, that we just talked about, so that we can eliminate the need for a password and be able to guarantee that that concept of KYC and knowing that the user is who they say they are. And so now we're going to go back to our payments. We can see the account balance has updated itself and stored. And so you can see all the recent transactions that you've put through. This time we're going to send a payment to Virtual Charlie, $110. We'll add a description. And what we'll be able to do is, again, see that ISO compliance in effect, but also we're going to be able to compare the encryptions a little bit. And so you can see the milestones hit in real time. They're all tracked. We have a safe delivery to Virtual Charlie, and now we can compare the encryptions a little bit. And as you can see, they're completely different, but we maintained that synchronization after the entanglement, the re-entanglement through our zero knowledge keypad. And so now what we're going to do is we're going to shift over to our core use case, our other core use case of messaging. And so this is where we'll be able to take a deeper dive. And what I'm going to be doing for you guys is splitting the screen and displaying Wireshark. And what this is going to do is it's going to demonstrate a few different things. It's going to, one, be able to see the packets intercepted in real time. And we're not using TLS. I'm running this locally to be able to demonstrate to you guys that if the TLS that was in use was ever compromised and you're using the SQE encryption, that's what you're going to be seeing in the Wireshark. You're going to see that application layer security that is wrapped around your data. In this case, is going to be messages. To provide some context, what you're seeing here on the right, we have our green, which is all the packets being sent from the front end to the SQE network. The blue is the responses, so the back end responding to the front end. And I'm going to scroll through a little bit of them, as you can see from the current session here. And you'll see that every packet, because we are now entangled, or we've been entangled, everything is encrypted with our quantum secure SQE wrapper that's happening at the bit level that we're going to get into a little bit now, further now. And so we're going to send an example message here to Virtual Alice. We're going to send just a typical message of hello, Alice, and you're going to notice a few different things. First, you're going to see that the message was sent. We got the confirmation from the SQE network. You also saw that the Wireshark picked up the request and the response from, you know, sending that message to Alice. And what we're going to see is we're going to be able to compare the packets that were intercepted. And that's just to prove to you guys and demonstrate to you guys that the encryption that's happening and being stored and displayed in this sandbox is exactly what you would see over an HTTP communication, or if TLS was ever compromised, you would see the SQE encryption. So you can see that we have our non-sensitive header here at the top, and then the rest is our encrypted payload. You can see 46, 56, 50 matches, and that's exactly what you're seeing displayed, that exact encrypted payload. And so what's really interesting is to kind of tie this into, and really powerful is to tie into what Hamid and Caitlin were talking about earlier. And that's that we sent a message as small as hello, Alice. And now what you're seeing is, at least because of how small it is, we're sending at least a kilobyte of encrypted data. And so now what we're going to be able to show is, okay, let's prove that bit level encryption. Let's prove that if you send the same character consecutively, you can see it matches it with the Wireshark. But if we send 6 of the same characters, a small message, 6 zeros, and we send it 2 messages back to back, you're going to see how fast time is evolving. The keys are different every time. and you're going to see the randomness between this encryption. And again, this is all happening at the application layer. So we just copied and pasted 6 zeros. We sent them consecutively. You can see they happened within a second of, apart from each other. Both messages sent. The Wireshark picked up on all the requests and responses. You can see the encryption that's happening in each of these the intercepted packets. And now let's view the encryption. And you can immediately see the difference between the two. They're completely different numbers, completely different packets, and you can see the zeros. There was no pattern between the zeros. We sent 6 zeros. We received a kilobyte worth of encrypted data, and this is happening again at the bit level. This is a bit level encryption, so it's happening at the bit level. Each character is receiving its own encryption, and the other part is the security aspect of it. If any one of these characters were tampered with, the responding would immediately know that they're unentangled and that this packet isn't valid and would be unable to be decrypted. And so this ensures a huge security, huge data. And this is, again, just the tip of the iceberg when it comes to overall use cases. You know, this can wrap not just around messages, this can scale to large packets, as Hamid had previously mentioned, you know, in the megabytes. The encryption is very fast. And as long as the two endpoints are entangled with each other, and we can do this not just between browser and server, but this can occur between server to server communication, hardware devices, IoT, and even mobile phones as well, as long as they have that zero knowledge principle to maintain and initiate that entanglement and to create that quantum secure channel. And so now I'm going to kind of bring this back to full screen and go into our information pages a little bit. And what I really want to talk about is kind of how this SQE encryption fits in the overall kind of architecture of like secure communication, right? So the standard and what a lot of people and a lot of applications are using the TLS, right? And so that's either HTTPS or WebSocket secured. But there's obviously known attack surfaces where if that TLS is ever compromised, we know the like Harvest-Now-Decrypt-Later. And if what this SQE encryption allows is an application layer security, so that if the TLS is ever compromised, then essentially what you would see is the SQE encryption, keeping your data safe essentially for the long term as well. And so how do these pieces fit? We kind of talked about this a little bit with the Wireshark. What does a network observer see? Well, you can use this not only as a secondary control with TLS, but it's also because we've eliminated the need for public key cryptography, you can send this over HTTP, and you just saw the encrypted packets that were sent and intercepted by Wireshark. And then we also have our table here that kind of compares if a TLS was ever compromised or exposed, how the SQE encryption kind of responds to that, right? So again, if that TLS is ever compromised and you're using the SQE encryption, then that's what you would see. It's an added layer that you can essentially implement into your own transactions. Again, it's fast and it's at the application layer as well without having to use public keys. We also have our compliance mapper here, and this is kind of what I talked about earlier with our ISO 222 payments is SQE is acknowledging and can comply with a lot of the standards of today, the KYC, the user authentication. We have this drop downs on this page that kind of go in depth of how SQE's encryption and SQE as an ecosystem kind of comply with the standards of today. And you saw in real time the secure messaging and the ISO 222 payments as well. And so this is really important as this is kind of how we continue to look forward on our roadmap. We want to continue to improve the KYC and the Keypad so that we can really verify users through their biometrics and be able to have that password login or passwordless login. Lastly, we have this portal that's powered by Netrascale that gives you the ability to create your own risk analysis report. And this is really powerful as well and allows you to sign up, register, and check that out as well. And again, for anybody that's really interested and we have a QR code that's available for you to essentially sign up, register through that QR code, and you'll be able to kind of receive a code that checks this Sandbox out in real time and really get your feedback and see this, again, test it out, navigate it yourself. So I appreciate everyone's time. Thank you.
Thank you, Jacob. Really appreciate that. Great presentation. And thank you, Hamid and Caitlin, for the session before. Very, very informational, lots of insights. So with the next session, we want to provide an opportunity to really kind of delve into some, what does the landscape look like? We're talking about cybersecurity risks that we face today, but we know that, very soon we're also going to have to address the real challenges that quantum computers are going to be creating as well. In fact, the NIST timelines for migration already started. And so it's really important we start to plan migration. If you look at what the Federal Reserve and many other organizations are saying, this is going to be a multi-year effort. It's going to require lots of change management internally and across the supply chain. So we want to have a robust discussion to start thinking about the immediate cybersecurity challenges and how we start to balance that with planning for the future of post-quantum readiness as well. And one thing I did, if you look in the chat, I popped in some FAQs from the SQ website. So please have a look at that. Some of the terms that Jacob and Hamid have kind of addressed, you'll be able to get a bit more, more of a deep dive. Okay, so please have a look at those FAQs. So one topic we're going to be doing now, I think with our esteemed executive team right now, is going to focus on crypto agility and how SQE helps to make a change in preparing for that future that we're talking about. So what is crypto agility? For those of you perhaps who are not necessarily in the cybersecurity domain, I've popped a link from the NIST website. Do have a look at that for a basic description. And with that said, we're going to jump straight into the executive panel discussion. So I'm going to start off with Glenn Benson, and Glenn and then the other participants, once you're introduced, please do a quick introduction after I've asked the question. So I should quickly point out my colleague, Rich is not able to join for moderation. Unfortunately, he's not able to make it. So we're going to kind of look to streamline the questions. And if you do have any questions, by the way, please pop it into the chat, and Mike and Joe and the rest of the team are going to be helping to kind of caption and share it with the team and make sure we get back to you. Okay, Glenn Benson, first question, please. In your experience, what are the most significant organizational obstacles? Examples may include system fragmentation, legacy integration, skills gaps, that financial institutions face when enabling crypto agility across distributed environments. Glenn? Do we have
Glenn
Glenn?
is muted.
Oh, he's muted.
I'm sorry.
No worries, it happens. Yeah.
Thanks. I'm Glenn Benson. I was the distinguished engineer in charge of security at JP Morgan, moved on to some startups and moved on to Santander, where I was head of security architecture for North America. That was US and Mexico. Answer to your question, that it's a good question, and good use of the word obstacle rather than barrier, because I don't think there's really barriers to doing this. So it's more like an obstacle course where you have a lot of hurdles and other obstacles to go through, but it's long and it's tiring. So it is a multi-year thing. It is the kind of thing where there's just a lot of things to remediate. You have to remediate your TLS, like we talked about before, but your IPsec, your certificates, your method of doing digital signatures, really anywhere you're using asymmetric cryptography. So it's just a lot. Now, there are a few real barriers, like there's some of the stuff that hasn't been standardized yet for quantum, for post-quantum, like IPsec doesn't have a post-quantum algorithms built in. So, that kind of slows things down. So, then there are other things. I don't think you want to do the upgrade to crypto agility in isolation. You want to do it in concert with other things, like your movements to the cloud. So if you have an application that is going to the cloud in the next couple of years, then why spend a lot of money remediating it when you're just going to throw away what you've remediated? And then the cloud has different solutions. So yeah, so it's to sum up, it's really an obstacle course with a lot of obstacles, and just have to keep it going for a while. And that's probably the biggest issue. It's just not one project and you're done.
And of course, planning ahead as well is going to be very important, as per the NIST timelines. Thank you, Glenn. Appreciate that. Okay, next question for Jeremy Sheridan. Jeremy, based on your investigations into modern financial cybercrime and blockchain abuse, what persistent and emerging fraud risks should institutions anticipate as crypto-agility projects scale? So quick introduction, please, Jeremy.
Yeah, thank you very much. Thanks for having me. It's a pleasure to be with everyone. My background is in law enforcement and investigations. I spent 25 years with the Secret Service, conducting financial fraud investigations and protecting financial infrastructure. I now am leading FTI Consulting's investigative work streams with a blockchain and digital assets practice. So in regards to your question, as has been discussed a lot today, we're very forward-looking in terms of technology advancement, quantum computing, and how that will affect the fraud and fraud mitigation landscape. Very difficult to encapsulate that in really a soundbite type of approach, because organizations and individuals need to conduct very thorough risk assessment to not only identify the threats, but identify how those threats impact their specific vulnerabilities as it relates to their organization and their prioritization and identification of assets. And that is part of the challenge here, different for each entity, each organization, or each individual. But there are a lot of persistent fraud risks that exist and continue to be present, regardless of all of those factors considered. And unfortunately, at the root of almost all of them is the human factor. Vulnerabilities around human error, whether it's in implementation or operation, execution, or otherwise, still continue to be the most prevalent and most effective attack vector, avenue of ingress, and subsequent fraudulent execution mechanism by the adversary. And so social engineering attacks that target employees in any type of crypto capacity, whether it's as a holder or as working in an organization or is some type of crypto provider, offer the most effective and prevalent way in which these frauds occur. And then those are leveraged for more advanced ways to conduct certificate fraud, such as forged or compromised digital certificates, taking advantage of key management vulnerabilities. We see a lot of issues with how keys are managed in terms of inadequate protection, leading to unauthorized access. And as we see more of the advent of these advanced technological approaches, legacy system exploitation, especially in transition periods when both old and new systems are running simultaneously, there's a lot of gaps in security that are taken advantage of. Those will continue to exist and be prevalent, I think, for many years to come. But as it relates to a lot of what we're discussing today, the emerging fraud risks around quantum computing threats, potentially compromising current cryptographic standards, and even maybe applying some of the old school ways with the new school of, investor fraud or platform fraud, claiming to have quantum security and taking advantage of users' lack of knowledge around quantum computing and quantum applications in order to defraud someone for an investment scheme or some other type of approach, as well as supply chain compromises that exist but will continue to be prevalent. Implementation errors, as we've discussed, as we move to these new methodologies. And I think compliance fraud, too, is something to discuss about how organizations can falsely claim cryptographic compliance or quantum capabilities while maintaining vulnerable systems will still present potential risks and threats to all users in the crypto space.
Point. Thank you, Jeremy. And I think that point around fraud is worth by me just highlighting a concept which is increasingly in the news, which is, of course, Harvest-Now-Decrypt-Later. This is something that is very difficult to quantify the risk because very often nobody really knows the value of the data that's being compromised or breached, apart from the actual owner. But the reality is to be able to put some price or some metric to determine what impact that has later down the line is very, very difficult, which is, of course, why it's important to be planning now and trying to build the barriers to prevent that actually happening in the first place, which is why I think technologies like SQ are very, very important. So thank you, Jeremy. Okay, over to our friend Simon Pont. First question, please, Simon. With EMV 4.0 and aggressive timelines for PQC migration, how do you see the adoption of crypto-agile practices impacting real-time payment systems and PCI compliance in day-to-day operations?
Yes, thank you, Dennis. Yeah, my name's Simon Pont. I have run, as a CEO, two software companies. One was in the healthcare industry, and recently, for the last 20 years, in the retail industry. So our experience is very much dealing with large-scale organizations, some of them global, some of them just based in the UK. I'm based just outside of London. I'm also a qualified lawyer, and so a lot of the legal side of this does interest me as well. Just to answer your question, I think, Dennis, part of the problem is quite clearly the PCI compliance. So credit card fraud in the UK, just in the first 6 months of this year, is 300 million sterling. So if you multiply that globally, it is absolutely a massive problem. And this is something that we've been working against, and EMV and PCI, EMV level 4, as we've arrived at now, works to push this back. But part of the problem is very much that there's a lot of equipment out there that just does not have that security built in. And if you think of the sort of smaller retailers, smaller hospitality sites, having something that would have this type of security that SQE is offering would be an absolute massive bonus. It would stop a lot of the leakage coming out of these companies, out of these organizations, which ultimately the payment service providers, the PSPs, have to pay back to the end client. So it's costing everybody a lot of money. And so if we could close that gap, close that door and stop this type of fraud, that would be fantastic. And a lot of that fraud is all about identity, which of course is what the product is designed to stop. So if we could get in there, if we could get something that's approved by PCI, and get it globally approved, because that is something now that has to happen, then I think it would be a massive bonus, and it could be a huge cost saver, as I said earlier. So yes, thank you.
Thank you, Simon. Appreciate that. And now over to Imran. Imran, question for you, please. How are leading financial institutions strategically aligning cybersecurity transformation initiatives such as cryptographic inventory, a migration plan with evolving NIST post-quantum cryptography standards, that backed up against regulatory expectations? So how are you balancing those kind of initiatives?
Thank you for the question, Dennis. Yes, this is a new arena for most of us, right? And it's in a constant state of evolution. But within financial services, I would say there are many ways that we are preparing for, and it has to take a methodical approach. So firstly, the institutions start with a comprehensive inventory of the cryptographic algorithm, which serves as the foundation. Big institutions like JP Morgan Chase and HSBC are prioritizing exhaustive inventories of the cryptographic assets and vulnerable algorithms in systems, applications, and third-party dependencies that can mitigate the big risk, which is Harvest-Now-Decrypt-Later. These are directly mapped to NIST 8411 for prioritization based on data sensitivity and lifespan of the data. Secondly, they are implementing migration roadmaps tied to risk and NIST guidelines, and with 2030 NIST deprecation and the 2035 allowance for legacy algorithms. Thirdly, they all realize that governance is an absolute necessity, so they are implementing robust governance and executive sponsorship by establishing cross-functional task forces and repurposing existing cyber governance to oversee migration, training, and accountability. So now taking this proactive approach with regulatory compliance and compliance with emerging regulations such as DORA and SEC, the compliance becomes the heart of this effort. Thank you.
Thank you, Imran. Yep, great point. I'm glad you touched on those regulations because, of course, it emphasizes the complexity involved in managing all these inventories and different initiatives while having to make sure that you comply. And of course, you're looking to protect your reputation as an organization as well. That applies not just with banking, of course, but pretty much any industry, to say the least. Thanks for that. Okay, so coming back to Jeremy, I have another question for you, please. Given that financial fraud still exploits human vulnerability, how should enterprises design their defenses against increasingly sophisticated threats that blend both AI, automation, and classic social engineering?
Yeah, as discussed earlier, the human element unfortunately still remains the greatest vulnerability. And that's along a lot of different verticals. That includes, technical controls, operational strategies, emerging considerations, operational implementation. And so the most effective mitigation approaches to that and to those vulnerabilities involve multi-layered defense in depth, it's often called, that applies technical approaches and technical controls to hopefully mitigate some of that human element. And a lot of those, are around zero trust architecture to verify access requests regardless of source, applying continuous authentication, that systems going beyond just point in time verification, that monitor behavior patterns, and really, I know it's overused and somewhat of a crutch, but leveraging AI-powered threat detection that can identify anomalous patterns that are indicative of any type of attack behavior. And weaving those into a technical control architecture is old school as it sounds. Email security still remains imperative, but a security framework that applies AI capabilities, they can pick up linguistic patterns or phishing attempts, or seeming bot or other AI-generated type of email construction, or deepfake attempts for synthetic voice or video that also applies behavioral biometrics and network traffic analysis. And as boring as it sounds, human-centered defenses. A lot of preventative approaches rely on proper training of personnel, training to specific job roles and access privileges, doing simulated AI attacks around some of the concepts I mentioned, having a incident response plan in place, not only that exists, but that is practiced, one that establishes and develops and maintains relationships both internally within an organization and externally with appropriate, either law enforcement or third-party vendors who provide security services, and building these into operational strategies of an organization, regardless of size, that has threat intelligence integration, has security orchestration, some level of automation, and a cross-functional security mindset, culture, practice and governance mechanisms built into place that, combined with the technological approaches, really build that and establish that defense in depth and meshed security architecture.
Thank you, Jeremy. Glenn, I'd love to delve a little bit more into that security architecture type. Of course, this is my domain as well, so great interest. Imran talked about Adora, and Simon mentioned PCI, the importance of compliance. In terms of the security architecture, what role does designing security architecture in close alignment with business goals play in achieving both luxury objectives such as DORA and PCI DSS? What's the link there?
Well, security architectures should really play a leading role in building the roadmap. And that roadmap is critical because it's, well, as we talked about before, it's such a long roadmap. And that roadmap really needs to take into account a lot of different things. And it's going to be kind of up to the individual company of exactly how you prioritize the different objectives. But the kind of things to put on the table are business alignment, the risk, like the Harvest-Now-Decrypt-Later, the ease of implementation, the readiness of standards in the industry, and you kind of put all those together and you build this multi-year roadmap. Now that multi-year roadmap really should be getting to compliance. And as far as compliance is concerned, architecture should be part of the company. I ran the architecture group for a couple major banks, and the idea is the whole InfoSec program should be really there to build good security, but good security and regulations, they should be kind of together. So when you're building good security, you really should be addressing regulations. I mean, yeah, you have to move it around some, but regulation shouldn't take it in one way and good security in the other. So as you have this InfoSec program that's built, in compliance with the regulations, you should have the architecture throughout it. One place that we haven't talked about so much is the third-party SaaS, right? The architecture should be involved in choosing the SaaS provider and then bringing them up to crypto agility and quantum compliance or post-quantum compliance.
Fantastic. Thank you, Glenn. Appreciate that. I think that's a nice little segue. Imran, coming back to you, I'd love to get the CISO perspective here. And so in terms of both from a regulatory standpoint, the question I have for you is, what hurdles do CISOs face when implementing crypto-agile architectures to maintain robust KYC assurance, especially under regulatory mandates like the New York DFS, SEC, GDPR for KYC and anti-money laundering? If you can delve into that, please.
Thank you, Dennis. From a CISO's perspective, there are many challenges for implementing crypto-agile architecture because at its core, in my opinion, crypto-agile architecture should be one that would dynamically implement a cryptographic algorithm based on the information that is being accessed, processed, or transmitted. So the first challenge that CISOs face is the lack of a complete cryptographic inventory and visibility. It becomes a painful task to document all cryptographic elements in the KYC systems, including embedded algorithms. Legacy applications, you have third-party dependencies, and so these further complicate the risk assessments for KYC systems. This also puts them at risk for disruptions when implementing a crypto-agile architecture. Now, regulatory burden further complicates this journey because regulations such as the Bank Secrecy Act and FinCEN mandate adaptation of standards like beneficial ownership and transparency. This then creates a silo between the security teams and compliance function in light of the tight compliance deadlines. Now, humans do play a part, and the most prominent gap here lies with the cryptographic expertise gaps within the environment. Finally, for a CISO, balancing enhancing crypto transparency with transparency, remains a challenge where CISOs face hurdles to ensure operability and auditability to prevent illicit activities within those systems.
Thank you, Brad.
Over to you.
Appreciate that. Great. Okay. So I think, a lot of and I should point out, a lot of discussion clearly is kind of focused around financial services, payments, but a lot of this stuff would resonate with those of you who come from other highly regulated sectors as well. And so I really encourage you to raise any questions, any kind of nuances you think that we should be reflected. Because as Jake and Hamid mentioned earlier on, the Sandbox is very much designed to help organizations create the use cases that are going to be of most value. When you think about what does a keyless encryption world look like? How do we start to create those use cases? We're really looking to get some ideas from you, so please continue to share them. And we've got some fantastic ones coming already. But thank you for that, Imran, because that was a fantastic segue. Right. Okay, Simon, I have another question for you. What are the most effective commercial strategies for accelerating secure technology adoption? Examples like post-quantum cryptography, your encryption key management platforms, while ensuring you retain customer trust and limit friction.
Yes, I think that's a big challenge, Dennis, because a large sector of the population are uncomfortable with a lot of the security issues that they already have to encounter. But of course, the downside of that is that, as I said earlier, there's still a huge amount of fraud going on, especially card fraud, but also advanced payments, etc., etc. So I think to keep people on side, there's 3 specific areas that I would suggest are quite important. Number 1 is the card fraud. We've got to overcome that. If we can just get that down, because that accounts for something like almost half of the total cash fraud globally. So if we could just manage that and get in there some form of security, whether it be password protection or whatever it might be, in the back end of the system, and I'm not talking about on the front end, pin entry devices, etc., etc., because I think that actually, in all fairness, is reasonably well covered already by PCI regulations. But securing the back end so that people can't break into an EFT, electronic fund transfer device, and ensure that we can keep that information and those costings safe. I think that's very important. That would not impact the customers. They already expect that, and I think they experience it and they respect it. Overcoming the fraudsters obviously is another matter entirely. But the second piece I was going to mention is that a lot of the fraud, for instance, Marks and Spencer's here in the UK, Adidas across the world, have experienced last year massive cyber attacks, which is in the back-end systems, so that it's meant that, for instance, customer accounts systems, where people have bought something on account and need to pay for it, have been broken into, and that causes a massive amount of issues and problems to these retailers. Therefore, to be able to give them that sort of security, I think, would be very, very important, and would help massively in terms of their customer profiles and ensuring that their clients, their customers, are comfortable and confident in purchasing things, because obviously that is a very major downside if they hear through the newspapers or on the television that a retailer has been broken into and has had that information stolen. People are going to walk away from them. Okay, and then the final part is that relationship between that retailer, that customer, and also the suppliers. So the supplier chain has, you know, as much money going through it as, of course, the retail chain does. And so being able to give that security to a supplier, to somebody that's selling to either an online site or perhaps a shop or a series of shops, again, would give a massive amount of security. And again, I think a lot of confidence to these people. So I think that end-to-end security system that SQE is offering would give a massive amount of confidence to these people.
Thank you, Simon. I'm glad you touched on the supply chain aspect, because we know that's one of the biggest risks within the value chain, and it's also very difficult to quantify because it tends to be extensive, multi-geographies included, and different regulatory considerations.
Yes.
And so it's a massive undertaking. It's something, in fact, at NetroScale, our team, the market research team, did a great job kind of like doing research into supply chain risk, and it's very difficult to manage. But of course, there are solutions, you know, with using AI and so on and so forth. So lots of opportunities for innovation there. Thank you. Great. So I think that's a nice kind of bringing back to Glenn to kind of like address those considerations, right? So trade-offs between cost, technical complexity, and some of those areas that and of course, regulation, Simon touched on. So, Glenn, I have the final question for you is, how can organizations manage the trade-offs between cost, technical complexity, and audit demands as they evolve their cryptographic infrastructure, particularly to avoid compliance fatigue under Federal Reserve Board, Office of Comptroller of the Currency, and of course, the Federal Deposit Insurance Corporation, which have their own operational resilience mandates? What does that look like?
Well, compliance fatigue is always there, even before you start. It's compliance is difficult, you know, and it's a big issue. Now, you do want to do, you know, I think talked before about remediating applications before you're about to deprecate them anyway. So I think that's one way to really address the cost, is to build this roadmap, you know, that takes into account things like that. I think in general, not always, but in general, you want to at least try to have some centralized utilities, you know, so you have your centralized IAM, for example, and then as opposed to having the whole organization being trained in all the details of security, you know, you build these centralized utilities, build APIs to it, and, you know, and the whole organization needs to work within those APIs and then depend upon those central utilities. And I think that will address the cost quite a bit. Now, those central utilities, you know, that's heavily influenced by that security team, is going to have that quantum roadmap, so that it should have the right crypto agility to address the post-quantum algorithms. I think that good standards within the corporation are really important. I don't think you want to have every single application need to understand every single regulation. You want to have an intermediary between the two, and that's where your standards can come in. So you build up the standards that comply with the regulation, and then each of the applications comply with the standards, and those standards should be something that is, you know, unique or at least dovetailed to that organization. And I think you do want to build to those standards, and you want those standards to comply with the standards that are required by the industry, you know, such as the post-quantum algorithms.
Absolutely. Thank you, Glenn. So Jeremy, I'd love to kind of come back to the law enforcement aspect. Perhaps maybe drawing on your law enforcement experience, what best practices help organizations build more proactive and crypto-agile defenses against during these migration periods, including the ones, of course, Simon touched on?
Yeah, and I think it harks back to previous answers around identifying that threat intelligence, what the primary assets for prioritization and protection are, what the vulnerabilities are, and what the realistic risk mitigation procedures that can be put in place are around all of those answers. And that's done similarly in those categories that we talked about around vulnerabilities in, strategic, technical, operational, risk management type approaches that really have to be done with a human element as an undercurrent. So strategically conducting a comprehensive inventory of all algorithms, keys, key management practices and processes, and how those are implemented across the enterprise, prioritizing that within the risk framework, and defining the cryptographic governance with clear ownership policies and decision-making authorities for those structures, and applying a technical implementation approach on top of that, that centralizes or has robust access controls and audit capabilities around key management, having crypto agility testing environments that allow you to simulate migration or threat scenarios or threat environments or actual incidents, having different abstraction layers to separate business logic from cryptographic implementations that will allow not only execution but future transitions, and having operational controls around those that have staged migration approaches if you're implementing new systems, have regular health checks throughout any type of standard or migration process, continuous compliance monitoring with real-time alerts, certainly very important. And having realistic threat modeling around all of that with necessary compensating controls so that you're organizationally ready. Again, applying back to making sure teams are prepared, understand the threats and vulnerabilities and responses, so that there's specialized training for security teams within those considerations. Very important to have executive level buy-in and reporting and communication between the frontline and working elements along with those with executive level decision making authority, and having ways to measure and improve along that process that not only tracks progress, exceptions, successes, and failures to reduce risk, but verifies proper procedure, proper implementation for any advancement, and maintains alignment with evolving standards and all regulatory and compliance requirements.
Thank you, Jeremy. Very important points. And one thing we're going to do, by the way, is we're going to provide some data sheets that are going to encapsulate a lot of these points. So please do have a look at those later on. But yes, I think having a robust understanding of migration planning as part of both the crypto aspect and all the other initiatives means that you're going to be in a much stronger position. Now, I think this is a nice opportunity to kind of like delve a bit deeper into that, because of course, before things get to law enforcement, if in the ideal world, if you have proper operation resilience practices in place, then you can minimize the damage, right? So I have a question for you, Imran, which is how should teams approach resilience testing and incident reporting in a rapidly changing threat landscape? Because I think it's fair to say there's insufficient time allocated to resilience testing, but please correct me if I'm wrong. Imran, you're muted, I think.
Sorry about that. One of the challenges of technology. Now, this is a very important topic you bring up, resilience testing, and yes, it is often ignored. Normally, what what organizations should do is establish comprehensive testing programs with scenario simulations. They should also incorporate rigorous principle-based testing, including but not limited to penetration testing, red teaming exercises, and AI-driven simulations to validate defenses. Additionally, they should integrate incident response with disaster recovery to ensure that one process calls the other, and this should be tested via regular tabletops and live play exercises. Now, resilience goes beyond keeping backups. It should also ensure that backups are reliable and available should we need them. So what organizations should do is look towards backup means beyond the traditional lift and shift that back up all the databases and infrastructure. So one such way to restore reliably, especially after a significant cyber event, is relying on transaction log backups, which is of course more time consuming and resource intensive, but an all-encompassing restoration effort. Now, lastly, they should also integrate continuous monitoring and threat detection into their program using real-time tools such as the SIM. Event log retention is an important aspect of resilience. Now, further to my comment on threat intelligence, I recommend that organizations also establish threat intel sharing between themselves and with the public sector. I covered this extensively last month at the Lone Star Cyber Summit. Now, in my experience, I've discovered that one of the fallacies of disaster recovery and incident response is that organizations tend to ignore that these are living, breathing processes, which must be continuously tested and updated so that we can adapt to the evolving threat landscape to contain and prioritize incidents effectively. Further to what Jeremy said, reporting is an important aspect of resilience. Hence, organizations must document all incident details, actions, and communications extensively. They should also promptly inform regulators and any concerned parties that need to be made aware of this. I have actually covered this quite extensively in my podcast on Form 8K filing. Finally, intra-company and intercompany partnerships are crucial for gathering and sharing this threat intelligence and post-incident analysis. Lessons learned and strategies to anticipate newer threats. Now, I will note that this public-private sector collaboration and intercompany collaboration served us well when we were dealing with the Log4j crisis. I don't know how many of you remember that, but yeah, this was crucial to that. Over to you, Dennis. Thank you.
Thank you, Imran. Very good point. I think cross-sector collaboration and cross-functional collaboration is absolutely essential. The bad guys are sharing information. We don't do enough when it comes to sharing, and I think we need to kind of change that mindset because, of course, the studies show that it does bring results. Very good points. And I've had a chance to work with your amazing cybersecurity team at BNP Paribas, as mentioned, and you guys do some fantastic work. So thanks for sharing those perspectives. I'd love to close with a final question for Simon, because, of course, If you remember back to the Sandbox use case Jake walked through, there was a strong emphasis on payments, and so we opted for the ISO 222 standard, which of course is the global standard right now. Why is this important? Well, it doesn't matter what the industry is. Reality is, if you have some online presence, there's some kind of currency exchange or value being exchanged in some form, right? So kind of representing payment is essential, whether that's crypto, whether it's traditional payments. We felt it's important to kind of highlight the importance of building an encryption model for the future. So with that said, Simon, I have a question for you, please, which is, in your view, how crucial is regulatory coordination across regions to advance payment system innovation in the context of global crypto agility requirements and varying implementation pace? Because not everyone's going at the same speed, so love to get your thoughts on that.
Absolutely. Thank you, Dennis. It's one of those things that now it is a global requirement. There's no question about that. I mean, I remember when in the early days of credit card transactions, you had different schemes. So you put up the information about EMV, which is Eurocard, MasterCard, Visa, which is the biggest. But back in the day, there was also China Union Pay had a different system. Amex was different, etc., etc. There was lots of different schemes, and that did cause a lot of problems with the retailers. And I remember specifically the airlines, for instance, struggled very hard to get a SOLAS system up in the air, because there was different people with different cards with different payments. So I think moving forward, if we can get a system that has security globally based, for every single, first of all, every single acquirer, but also every single card system, I think that is very, very important. And I'm actually fairly sure now that that would actually have to be a specific requirement. I don't think there will be any areas of the globe now that would not want to be part of a system. And the fact that SQE can offer that system that would go across the board, I think is a very huge bonus.
Very good points. Thank you, Simon. So that's a fantastic ending to our panel discussion. Thank you so much, everyone, for taking part. I'll just kind of quickly highlight, if you want to book a consultation session, Joseph Scalise and Michael Goodwin are going to be sharing some QR codes. If you don't yet have them, please let us know. It's on the screen right now, so feel free to take a quick scan of that. And of course, we're going to be sharing more information afterwards. If you're interested in Risk Act, we're going to be continuing our journey with our demos. We're working some clients, prospective clients right now. So if you understand your risk or your threat landscape in more detail, please feel free to reach out. We'll be happy to share more information and show how we're going to be helping to advance the Sandbox and other initiatives as we onboard new use cases. So thank you so much for everyone for taking part. Really appreciate you all, Caitlin, Hamid, Jake and team, and all the executive panel members, all the team working in the background, and of course, all participants in this event. We could not thank you enough. Thank you so much and have a wonderful day.
Thank you, everyone.
Thank you.
Thank you. Right.